Hello everyone, welcome to my channel. In this video we're going to solve this given exponential equation, a math Olympiad question. 8 to the power of x minus 4 to the power of x equals 2 to the power of x. And in here we're going to solve for the values of x. And without further ado, we start solving the equation. So 8 to the power of x minus 4 to the power of x equals 2 to the power of x. So let's divide the whole equation by 2 to the power of x. And from here, what you notice, they're all the same exponent x now, right? So here we have the exponent formula. Since we have the same power or exponent, it's from the formula we have a to the power of m or b to the power of m is equal to a divided by b to the power of m. So let's do that. On our equation we have 8 divided by 2 to the power of x minus 4 divided by 2 to the power of x equals 2 to the power of x divided by 2 to the power of x, that is 1. Now let's simplify. 8 over 2 is 4 to the power of x minus 4 over 2 is 2 to the power of x equals 1. So now from here I see a relationship between these two bases, 2 and 4. Now I'm converting 4 to base 2. So this is now 2 to the power of 2 to the power of x minus 2 to the power of x equals 1. And if you notice, the first term can be written as 2 to the power of x to the power of 2. This is from the exponent formula again. From exponent property, if we have, let's say, a to the power of m raised to the power of n, can be written the same way as a to the power of n to the power of m. So what that means is we just switch their exponents since they can be multiplied together anyway, right? So now that we have in here, so that's the result of that. Now the second term, minus 2 to the power of x, and we're moving the constant 1 from the right to the left, so this is now minus 1 equals 0. So now what did you notice? We have 2 to the power of x, and here second term 2 to the power of x, and here to the second power, that's the first term. So from here we're using the substitution method, right? Let's indicate u, or let's substitute u as equal to 2 to the power of x. So in our equation we have now u squared, that's from here, minus u minus 1 equals 0. And from here we're using the quadratic formula to find the value of u, right? The coefficient here is 1 and here is 1. Coefficient of a, the coefficient of the first term to the left, and b coefficient of u, the middle term, and then c corresponds to the constant -1. So from the quadratic formula we have u is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. And here all we have to do is just plug in the values of those coefficients and the constant c over here, right? So minus b is minus 1, so that becomes 1 instead, right? Minus and minus become positive. Then plus or minus the square root of b squared, 1 squared, so that's 1. Minus 1 squared minus 4a, a is 1, and c is -1 divided by 2a, where a is 1, so 2 times 1 is 2. You have here the value of u is equal to 1 plus or minus square root of minus b squared, so that is 1, minus 4 times a is 1 and c is -1 divided by 2 times 1, right? A is 1. This is equal to 1 plus or minus square root of 1, 4 times -1, that's -1 over here, and this is negative, so positive 4, so plus 4 divided by 2 times 1 is 2. And this is equal to 1 plus or minus square root of 5 divided by 2. So from here we have two values of u. First value is the positive square root of 5, so that's 1 plus square root of 5 divided by 2. That's u sub 1. And the other value of u sub 2, we're using the negative square root of 5, so that is 1 minus square root of 5 divided by 2. And let's recall that u is a substituted variable in place of 2 to the power of x. And from here, u is an exponential function, so it cannot take a negative value of u. So this one, we are rejecting this value of u. Alright. So we'll be using this value, u sub 1. The positive is square root of 5 plus 1 over 2. Okay. So now we have 2 to the power of x is equal to the value of u, 1 plus square root of 5 over 2. And from here, we're taking the logarithm on both sides of the equation. And the exponent x going down to the front. From the exponent power rule of logarithm, we have log of b to the power of c. This is equal to c times log of b. That means the exponent is going down to the front. So the exponent c is going to the front. So that's what happened to our equation now. X is going to the front of log of 2. So x times log of 2 is equal to log of 1 plus square root of 5 over 2. We take this further away a little bit. Alright, it's right there. So now solving for x, that means we're dividing both sides by logarithm of 2. So this one cancels, so we have x is equal to logarithm of 1 plus square root of 5 divided by 2 divided by log of 2, or we can put that as the base 2. Log base 2 of 1 plus square root of 5 over 2. So this is now the exact value of x. And by using our calculator, we can compute that by using our calculator. So x is approximately equal to 0.6942. So these are our answers. Well, it's the same, but this is the exact value and this one is the approximate value. And so now let's check our answer, the value of x. And we have here our original equation. Plug in the value of x, approximately equal to 0.6942 in our equation. So 8 to the power of x is approximately equal to 4.2356. Minus 4 to the power of x is approximately equal to 2.6179. And is this equal to 2 to the power of x? And this is approximately equal to 1.6179. Subtracting these two quantities, this is approximately equal to 1.6177. And this is approximately equal to the right hand side, 1.6179. So there's a discrepancy of 0.0002 right here, right? 7 and 9. So it's just confirmed that the value of x that we got is correct. And so that's all for now, and thank you for watching. And for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. You can share this video if you want. Feel free to share it to your friends and classmates so they can learn this kind of technique as well. And have a great day, everyone. Take care. I will see you in my next videos. Have a great day. Thanks. Bye-bye.